I am Dr. Prakash B. Nangare. Today I am going to present a lecture on gradually varied flow. What is gradually varied flow? Actually, it's a type of varied flow. So when the depth of the flow is gradually changes for a longer distance, then such type of the flow is called the gradually varied flow. So the varied flow is a non-uniform flow, and this flow is classified under the two categories. Out of that, the second category is a rapidly varied flow. When the depth of the flow is abruptly changes for a shorter distance, then you call the rapidly varied flow. So today you have to discuss about the gradual varied flow. So the gradual varied flow is nothing but uniform flow. It is a uniform flow requires a channel of constant cross section and sufficient length for the gravitational forces to balance the frictional resistance. So this is the requirement of the gradual varied flow. Because of that, the depth of the flow is a changes for a longer distance, and this condition is also observed in case of the uniform flow having the constant cross-sectional slope or cross-sectional area of this channel and have the sufficient length for these gravitational forces. Let us see the diagram. When you have see in this diagram, and the depth of the flow is to be like that. Y1 is the depth at the earlier section, Y2 is the depth of the flow at the further section. Then we have to observe for the uniform flow what is the exact condition for the uniform flow, where is the dv by ds is equal to the 0, means the change in the velocity with respect to the space is equal to the 0. Then as for the normal depth of the flow, so the y1 is also equal to the y2. This is the condition you have to be observed, and summation of the all the forces is equal to the 0. And this resistance force, that is the weight of the water, is acting in the downward direction, and w sine theta is a component acting in the direction of the flow. W cos theta is a component acting normal to the direction of the flow. So the resistance force you have to be worked out by this w sine theta is a gravitational pull, and you have to be observed this w sine theta is also acting in the direction of the flow. Suppose I have to consider the length bounded in between the two sections. This is the section 1, this is the section 2, and length in between these two sections have the L. Then further equation will find out at changes in the cross section. Suppose you have to be observed the normal depth. In case of the uniform flow, always the depth of the flow is equal to the normal depth, or the depth of the flow at the uniform flow is nothing but the normal depth. Then if you have to compare, suppose the any obstruction across the flow of the river, it may be the construction of the bridges, or it may be the construction of dam, it may be the construction of the any hydraulic structure. And due to the construction of the structure, so the depth of the flow is to be raised up, and this is the blue line which indicates the depth of the changes in the depth of the flow you have to be observed because of this obstruction, because of this hydraulic structure. So the yn is the normal depth of the flow, yc is the critical depth of the flow, y is the actual depth of the flow. So let us see about in case of this, compare these three depths: normal depth, critical depth, and the actual depth of the flow. So in gradual varied flow, at changes in a cross section, slope or roughness parameter, the two forces will not be balanced, and the flow condition will adjust towards the equilibrium. In gradual varied flow, within the channel reach where this adjustment occurs, the flow is said to be the varied or the non-uniform flow. If the changes in the flow conditions occurs gradually over the relatively the longer distance, then flow is said to be the gradual varied flow. Then let us see the diagram. If you have to see the hydraulic gradient line and the total energy line diagram, so you have considered the two sections. At section 1, corresponding head as a potential head is equal to the y1, datum head is equal to z1, and kinetic head is a v1 square by 2g. Or in other way you have to call as this is a potential energy, kinetic energy, and the datum energy. So summation of all this energy, you mark the point at section 1 as per the energy gradient line. For hydraulic gradient line, we are considering only the piezometric head. At section 2, you have to observe the changes over this depth, that is the datum head is changed, depth of the flow is changed, velocity head is also changed. But the if you have to be observed, this red color line indicates the total energy line, and differences in between the two sections you have to be observed in terms of the hydraulic loss. So this vertical ordinate from this horizontal line itself, it represents as the total energy line or energy gradient line for the ideal fluid. And you have to be observed this loss, that is hydraulic loss, in between the section 1 and the 2. Already you consider this section 1 and the 2, which is now equal to HL1 dash 2 now here. And you observe these changes, and total head of the water is available at this channel is equal to the H. And as per the Bernoulli's theorem, you know that is the summation of the potential energy, kinetic energy, and this datum energy is also the constant. Therefore, the summation of all the energies represents as the total heat. Then what about the gradual varied flow? As per the gradual varied flow, so the velocity here v square by 2g is replaced by this term q square by 2g a square. Because of that, the velocity is nothing but ratio of this q and the a, only simplification. So you have to differentiate this equation with respect to the x. X is the direction of the flow, is the length of the channel. Then you are getting this equation dh by dx is equal to dy by dx plus dz by dx. If you are differentiating this term, then it becomes minus q square by ga cube into the dA by dx. Then let us see the what is dh. Change in the depth of the flow is nothing but this vertical ordinate as a dh. Then corresponding energies at section 1 and the 2, and the length bounded in between the section 1 and the 2, you that means it is shown here as a dx. If we assume a wide channel and a per unit width consideration, q square by ga cube into dA by dx is equal to q small q square is the simplifications. Where is that the q square by a square? If you are taking this q is the unit discharge, and this unit discharge is represents as the capital Q by B. Q represents the total discharge and B is the width of the channel. So dH by dx represents the slope of the energy gradient line. If you are differentiating the head loss equation with respect to the x, which represents as the slope of energy gradient line, which denotes the symbol SF, F as a suffix due to this friction, and which is now the positive in the downward direction. dz by dx is the channel slope, which indicates the bed slope of the channel, which is positive in the downward direction. So therefore, substitute all these values in the earlier equation. You will be getting this equation dh by dx is equal to dz by dx plus dy by dx minus q square by gy cube into the dy by dx. Then substitute this dh by dx is represented as a minus sf, or this is the energy gradient line slope. dz by dx represents the bed slope of the channel, and simply you have to simplify, that is dy by dx is taken outside. Remaining term is 1 minus q square by gy cube. So the v by root of the gy, it indicates the Froude number. So Froude number is nothing but the ratio of the inertia force to the gravity force. It is represented by this mathematical equation as v by root of the gy, or the q by y into root of gy. So Froude numbers, if you are squaring this, then this parameter becomes the q square by gy cube. Then simplify this equation. Therefore, if you are putting these values, then you will be getting this equation dy by dx is equal to SO minus S by 1 minus FR square or F square. Actually, FR square, FR is the symbol for the Froude number. So the dy by dx, that means the the water surface slopes. Yeah, it may be represented as a SW. It is equal to the SO minus SF divided by 1 minus FR square. This is the dynamic equation is obtained for the gradual varied flow. So the dy by dx is the slope of the water surface with respect to the channel bottom. Then some points are going to be highlighted. If this equation dy by dx is a positive, then productions under this gradual varied flow is classified as, if dy by dx is a positive, then the water is getting deeper in the downstream direction. If dy by dx is negative, the water is getting shallower in the downstream direction. If dy by dx is 0, then the flow is totally uniform flow. And for normal depth yn, it is denoted by the symbol yn, suffix as n, is the depth of the uniform flow for a given channel slope and the roughness parameter. Critical depth yc is the depth of the flow where the flood number is equal to the 1 and is independent of the slope and the channel roughness. Then certain impressions or the certain productions over this gradual varied flow. If this normal depth is greater than the critical depth, then the slope is termed as a mild slope, and which denotes the symbol capital M. If yn is less than yc, then slope is termed as a steep slope. If yn is equal to yc, then slope is termed as a critical slope. A slope that is a negative or run uphill in the downstream directions is termed as adverse slopes, and a channel with no slope is said to be the horizontal. So these are the classification of the channel has been made by comparing the results of this normal depth and the critical depth. So these are the types of the surface slope channels, and you are going to be considered here, and according to that you have to be determine this if y is greater than yn and yc flows is said to be in zone 1 and denoted with a subscript 1. So if the depth of the flow is lies in the first zone, so the depth of the flow, so therefore which is greater than the normal depth, then you called as the zone 1. Then y falls between the yn and the yc, then flow is under the zone 2. And if y is less than yn, then yc flow is said to be in the zone 3. So according to the actual situation of the depth of the flow, so there are the three categories of the zone: zone 1, zone 2, and the zone 3. Zone 1 represents as if the depth of the flow is greater than this normal depth and the critical flow, and if the depth of the flow is lies in between the normal depth and the critical depth, then the entire zone is 2 zone. And if the depth of the flow is below the normal depth and the critical depth, the entire zone is the zone 3. Then according to this surface profile classification, based on these zones, if yn is greater than y, then bed slope of the channel is less than the energy gradient slope. Also, if yn is less than depth of the flow, so the bed slope of the channel is greater than the energy gradient slope. If bed slope is less than or equal to 0, then normal depth is not to be defined. So this is the way to classify the flow as well as the surface profiles.